Professor Liu is going to introduce the second very important concept at chapter 7 is creating a class. So we are going to create your own class right now. We still use your example square class. Okay? So when you start it, you do class and with class name declaration. So the declaration here, you have private and public. Private is for member variables. Public or public part are for the member functions. Remember, if we combine data, so member variables and member function together, this is a combination of member variables site, member function set size and get area. So this is abstract data type. So you create a class called square. It allows you to initialize another object, and you will be allowed to set size, and this small class will calculate the area for the square. So also we need to remember right here, so we have here the class square, okay, and we are going to so square is your class, then the objects. So now we separate them, okay, so we have a square class. Now we're going to use the square class because it's object-oriented programming. That means we encapsulate the the member and the function into one unit. That's an encapsulation. So once we do that, we have square. We can do square 1, square 2. I create another 2 objects. Okay. Once I create the objects, so square 1 and square 2 are the object I create. Then I was given the privilege to use the function, the member function of the square class. The square class has two member functions. One is set size, the other is get area. And you notice both objects, square SQ1 and SQ2. So line number A, SQ1 set size. So SQ1 is allowed to use the function member function set size, which was created from the square class. And SQ2, that's an object, is also allowed to use set size, which is a member function from the square class. And both of them also use the get area. All right, so now let's learn something. When we create a member function, okay, and we wanted to have two types. One is accessors, that's to get, together functions, together information, like you get size and get area. So this type of the function, you get get data, but you does not modify a member variables. This is called accessors. Whenever you use accessors, you usually use get, get. The other type is called mutator. Mutator, you set, and you modify a member variable. For example, we do set size. Because before we do set size, the size is 0. It's default to 0. Now, once you set size, the value was modified. Also, we need to learn this, okay? Whenever we wanted to use the member function, we use a scope resolution operator. It's a colon colon. Okay. Then let's check one more time, review it. When I want to create a class, I need to have the class function prototype. So the prototype basically, tell the Visual Studio, the class you want to create, what are the member variables like site, what are the member functions. Here are set size and get area. Then you need to have a class function definition. So then you have the definition to for this one, set size is a mutator type of function. It will modify the size. All right, and get area is the accessors type. It just retrieve the value, but will not modify the size. Okay, because we do return, we don't modify this. One more time, member variable usually private. Okay, member variable is private. All right, accessor and mutator and whatever the function, member function are public. Whenever it's accessor, let's use get, like get area. All right, or get size later. And if you use a mutator function, use set, like set site. Okay, now we are going to talk about constructor. A constructor is a member function, which is often used to initialize data members. It is called automatically when object of the class is created. The reason is constructor is the exactly same name with your class. And it must be a public member function. Okay. And it has to be exactly the same name as the class. So let's try to see how do we do that right now. Okay. So I have a class already. All right. So class square, that's my prototype definition here. And the third party use another programmer and use this program. Okay, so I am going to create constructor. All right, so I am going to create constructor. So constructor is a member function. Member function has to be in the public side, so I put public. Okay, and member function, remember it has to be exactly the same name. Has to be exactly the same name like your class. So my class called square. My constructor need to call square. So SQUARE. Okay, so I create a constructor right now. So the constructor is basically used sort of like a set site. Set size you are allowed in the user program set, but for here we'll automatically call. Let's see right now. Okay, let's see right now. All right. So first of all, I am going to let it create a function definition. Is that okay? So I got here right now. All right. So I am coming to here right now. Okay. So usually we just let's make size 0 doesn't help you too much. Let's make a size as 1. How about that? Okay. So size equal 1. All right. So now I have a constructor right now. I have a constructor. All right. So when I call my class right here, it automatically set the size to 1. Okay, so let's do this right now. Let me show you. I'm going to call this an SQ3 right now. It's okay. So my SQ1 and SQ2, they set size. But look, my SQ3 right here. Okay, so my SQ3. Okay, so as soon as I have my SQ3 right here, I don't need to do anything. I don't need to do anything because it's already automatically set to 1. So let me show you right now. So I'm going to copy this thing, okay? I'm going to say the third one. All right, I'm going to say the third one. And the third one is SQ3, is that right? SQ3. All right, so SQ1, we know is 25, 9. It is, here we are looking for 1. Okay, so let me run it right now. So build it. And start without debugging. All right, so the area of the first one is 25 because I set size to 5. 5 times 5 is 25. The second one is 9 because I set size to 3. 3 times 3 is 9. The third one, I did not set size, but I have a constructor right here. So constructor will automatically set it will automatically set size for you. All right, and this is very, very useful, and it's very, very smart too. Think about it. When you call this class square, and the constructor is called automatically. Okay, so let's come back to here. So we have the constructor right here. Okay, then we are going to say there are 2 ways to call constructor. One is called inline. So for example, here I have only 1 line here. If I have only 1 line here, all right, so this is I call this one is I call inside outside. Okay, but I can also do this. Okay, if I want to do the inline way, I am just do this psi equal s. Okay, psi equal 1. Okay, we just do like that. Okay, so then we don't need the definition. All right, so right here, if we just say psi equal 1, then we don't need the definition. Okay, we don't need to write here. Okay, now I am going to show you what is overload. All right, so overload constructor is, remember, overload is you are allowed to have more than 1 constructor. The more you want to have more to allow user to be flexible. They want it to be no argument. They want to be no integer, and they want to be they want it to be a double, whatever. So let's see here right now. Okay, let's see here right now. So right here I have a square right now. Okay, so I'm going to call another square, but this one I am going to put right here is double and s. Okay, and I'm going to put this side equal s. Okay, I put inside here. Okay, so I put the inline. So this one is an inline constructor. This one is an inline constructor. All right, so now it's overloaded, and can you see? Because I have a square. Square doesn't have the argument. You don't need to put anything. All right. Then, but the other one is also called square, but it has 1 variable right there. So let's see how do I do this. So I'm going to, right here, I'm going to have my square 4. All right, my square 4. All right, so, and I have a square 4 here. So once I have a square 4 here, then I will be able to give a variable here. Okay, so remember your square 4 need to give a value. Okay, so I am going to give 10. Okay, so square 1, square 2, I come here to set size. Square 3, I take a constructor square and set to 1, and square 3 use a default constructor, and square 4 use a inline and mutator constructor. That means you take the value, you're going to change, you're going to give a new value right now. Okay, so let's run this program right now. So build it. And oh, sorry, I haven't do square 4 yet, so forget it. It's all right. I'm going to copy this thing. I'm going to say the fourth. All right, and this is SQ4. Okay. All right, so I need to rewrite it, rebuild it. So rebuild it, and I'm going to start without debugging. So this time right here, based on the program I gave you, the SQ3, I'm using a default constructor. All right, then that means I don't provide a value. I just say SQ3. Then the program will say, okay, you don't give me anything, that's 1. All right, so SQ4, I give 10. So you see the difference from SQ4 and SQ1 and 2 is SQ4 automatically take that 10, assign to site. So it's faster. Okay, now let's take a look this program right here. So I overloaded. I have square, and I have a default constructor. So right here, default constructor, I have a mutator constructor. All right, so I evoke constructor. So here, the way to evoke constructor is SQ3, I evoke default constructor. Right here, line number 7. SQ4, I evoke a mutator constructor. Right here, line number 8. Also, my mutator constructor, I write it as an inline constructor. It doesn't matter it's inline or outside, but I just need to show you how to do inline. You can do outside, all right? I would like to write outside as a beginner because this way is more clear. Oh, okay, my default look like that one. My mutator look this one. But I just do like this way because as an instructor, I want to show you how to write an inline constructor. Okay? Now we are coming right here, right now. Destructor. What is a destructor? Okay? So, and right here, okay, we don't have it. You know why? Because usually Visual Studio 2019 already don't do that. But if you want to do it, you do tilde. Okay, where's my tilde? Tilde, SQ, okay? You do like that way, okay? And you don't write anything because, and you write here. All right, so that's all, okay? And you don't need to write any code for that because Visual Studio 2019, starting 2018 already. Okay. Destructor is a public member function automatically called, so no worry about it. And it will destroy your objects. Destructor with tilde, no return data type, takes no argument, only one destructor is allowed. It cannot be overloaded, and don't worry about it. You don't even need to write it because it will be written underneath. Visual Studio will write for you. Isn't that cool? Okay. And let's take a look. The other thing we also need to learn, even though we don't learn it right now, we don't have it, but in later chapter we need to use it. So we want to pass object to a function. So, in the internet, probably we want to pass bunch of the users information. Every user is a class. So when we pass that, and it can be very big. Is that right? So you don't want to pass by value. When you pass a by value, it's going to copy everything, the local variable, this and that. So what we need to do is when we pass an object, a class object, we usually need to pass by a reference, So using a reference parameters speed up program and allow the function modify data in a perimeter. So very important to save space and time, and also protecting parameter data that should not be changed, right? So we wanted to pass, okay? But once we pass, use reference, we have a little bit risk about that they may modify your data. So in order to not allow, to give them restriction, not allow them to modify your data, you still pass object to the function, but you are going to use a constant reference. All right. So here, void show data, and you show square. You put a const right here. So we pass it. We pass the entire square, but the square will not be changing. In order to do that, for the show data to call square member function, all right. So you also need to use const. In the prototype. So remember right here, const square as, this is a constructor, right? This is your constructor, and get size. So right here you need to const. We don't use in this chapter, but we do need to use 2 chapters later. So you need to understand that, and in the future we are going to use it. All right, we also returning object from a function. All right, we don't use that in this chapter, but we do use in the future, like when this one square initial square s, and we do everything here, return s. That s the square. We entire return a object. All right, so we will use very heavily about object composition. That means one object include another object, and we probably have 2 or 3 objects used interactively, starting from a few chapters later. All right, and another thing is use separate files. We always use separate file. You already saw how we use separate file, because if we are going to place a class declaration in the header file, and we are going to use the member function definition at the CPP file. That's called class implementation. All right, and we make sure we include it. And the third one is a client program. Client code. Use the class, must include the class specification file, and and be compiled and linked with. Okay, so let's take a look here right now. So one more time, we already separate, and we must separate them. Once we separate them, take a look what we have. We're supposed to have a .h file, header file. Header file is the class declaration. All right, then we have square.cpp. That's our class implementation. Class implementation, so you provide the definition for all the function. And use square.cpp is a client. Client is another programmer. The another programmer is using this class. And in this client uses square. Client can create many objects. So this is called object-oriented programming. So let's take a look right here. What, before, inside or outside the class should be designed to provide function to store and retrieve data. So whenever you want to design a class, in your mind, you just need to know your class need to be able to store and retrieve data. Input and output should be done by function that use class objects rather than by class member function. All right, so that's the concept of creating a class. I hope you like this video. I hope this video help you to understand.